You know, our electrical grid, it's probably one of the most complex machines we've ever built, but wow, is it under a lot of pressure right now? So today, we're going to dive into a really fascinating solution, an idea that was actually pulled from aerospace and manufacturing. It's called the digital twin, and this virtual ghost just might be the key to keeping our lights on.
I mean, seriously, what if we could see a massive power surge from electric vehicles before it even happens? Or predict exactly how a wildfire might threaten power lines, and then reroute electricity, way in advance. And look, this isn't some far-off sci-fi fantasy. This is the promise of a technology that gives our aging grid a predictive, almost clairvoyant power.
Okay, so why all the urgency? Why do we need this crystal ball right now? Well, it's because our grid, which, let's be honest, is a marvel of 20th century engineering, is being pushed to its absolute breaking point here in the 21st.
Yeah, this quote really hits the nail on the head. The very DNA of our power system is changing at an incredible speed, but the tools we're using to manage it, they're just lagging way, way behind.
All right, let's really dig into what's going on here. For starters, power is now coming from all over the place, from unpredictable sources like wind and solar. Then you've got these huge new demands, like entire neighborhoods plugging in their electric cars all at the same time. On top of that, our basic models of the grid are often just old, which means we're making big decisions based on bad info. And get this, we're collecting billions and billions of data points from smart devices, but most of it is just sitting there, completely unused. And finally, all of this complexity creates a whole bunch of new weak spots for everything from cyber attacks to climate-driven disasters like wildfires. It's a lot.
Okay, so you've got this perfect storm of problems, right? What's the answer? Well, engineers are turning to a seriously powerful new concept, the digital twin. This is the technology that's really designed to bridge that gap between the grid of the past and the one we desperately need for the future.
Now, what's fascinating is that this idea, it's not actually new. It has its roots way back in the Apollo program. See, NASA built identical physical twin systems right here on the ground to mirror the spacecraft up in orbit. So if anything went wrong in space, they could test out solutions on the Earth-bound twin first. Genius, right? Now, you fast forward to today, and that same concept has been totally supercharged by IoT sensors, artificial intelligence, and just massive computing power to create a virtual copy instead of a physical.
So when we say digital twin, what are we really talking about? Well, put simply, it's a super detailed virtual model of a physical thing. Could be a transformer, a substation, or even the entire grid. And the two magic words here are dynamic and real-time. This isn't just a static blueprint. No, it's a living, breathing, digital copy that is constantly changing right alongside the physical grid.
This visual here, it just perfectly captures the whole idea. You can see how the data flows from the physical grid on the left over to the digital twin on the right, keeping it in perfect sync. This is where the magic happens. We can run all sorts of what-if scenarios on the twin. What if a power plant suddenly goes offline? Where's the absolute best spot for a new solar farm? The insights from those simulations then flow back to help us run the real-world grid better. It's this constant super smart feedback loop.
To break it down even further and kind of demystify it, experts talk about 5 key parts. So you start with the physical thing itself, right? The actual transformer. Then you build its virtual model. The data is that constant river of information flowing between them. The service interface, that's where all the cool analysis happens. And the connection is just the network that makes the whole thing talk to itself. Simple as that.
Okay, so this isn't just theory or some cool concept on a whiteboard. One of the most ambitious digital twin projects anywhere in the world is happening right now in Europe. Let's take a look at the Twin EU project and how it's bringing this idea to life on a truly massive scale.
And when I say massive scale, I am not kidding. We're talking about 75, count them, 75 partners. These are utilities, tech companies, research institutes, you name it, spread across 15 different countries, all working together to build a digital twin for the entire pan-European power grid. It is a huge collaborative effort.
All right, I know this diagram looks a little intimidating, but the core idea is actually super clever and honestly pretty simple. Instead of trying to build one giant monolithic piece of software, they've designed it in layers. Kind of think of it like a pyramid. At the very bottom, you've got all the raw data streaming in from the physical grid. The middle layers are all about processing and securing that data. And at the very top, you have the workbench, the tools that operators actually use to run simulations and make decisions. This layered design is what lets the whole system grow and adapt across an entire continent.
And this is maybe the most important takeaway about how they're building this.
They're not trying to build like one giant God mode twin for all of Europe. Instead, they're building what's called a federated ecosystem. The best way to think about it is like a team of teams. Each country or even each utility can have its own local digital twin for its piece of the grid, but they're all designed to talk to each other, to share crucial data, and to coordinate their actions across borders. Okay, so that all sounds great in theory, but what does this team of teams actually do in the real world? Let's look at some really cool specific examples from the TwinOU pilot projects that are up and running right now.
And right here, you can see just how flexible this tech is. So in Germany, the focus is really on data and automation. They're using the twin to get a much better real-time picture of their grid and to automatically hunt for errors in their models. But then you look at the Iberian Peninsula, Spain and Portugal, and their focus is more on the physical stuff. They're using the twin to figure out the best way to upgrade their local grids to handle way more solar panels and wind turbines. Same tech, different problems.
And it just gets cooler from there. The uses are all over the map. In Spain, they're using twins to simulate weather patterns to find the absolute most efficient places to build new renewables. Portugal is simulating disaster scenarios to make their grid tougher. Over in Greece, it's all about the money. They're building market simulators to make energy trading more efficient. But this one from Hungary might be my favorite. Check this out. They're using AI to measure the exact temperature of power lines in real time. Now that sounds simple, but it means they can safely push more electricity through the exact same wires they already have. That's a huge deal for efficiency.
And if you're a numbers person, here's the proof in the pudding. This table shows how good AI models are at spotting problems, like cyber threats, on the grid. Look at that bottom line. Without a digital twin, a pretty sophisticated AI model is accurate about 87% of the time. Not bad. But when you feed it the high-quality, real-time data from a digital twin, its accuracy jumps to almost 92%. Now, a 5-point jump might not sound like a lot, but in the world of grid security, that is absolutely huge.
But let's be real, building a digital nervous system for an entire continent, while it's not exactly a walk in the park, the potential is enormous, for sure, but there are some pretty serious hurdles to clear on the road ahead.
First up, the huge, messy problem of data. You've got 75 partners, right? Each one has its own legacy IT systems, its own data formats, its own protocols. Getting all of those different systems to speak the same language so the twins can actually work together, that is a monumental task. Next, and this one is the biggie, cybersecurity. Think about it. When you create a perfect virtual map of your electrical grid, you also create an incredibly tempting target for hackers. Securing this digital layer is absolutely paramount because an attack on the twin wouldn't just be a data breach. It could cause real physical chaos. And finally, you just have the sheer challenge of scale. It's one thing to run a few successful pilot projects in certain regions. It's another thing entirely to scale that up to a fully operational, totally reliable system that covers the whole continent. This is going to take decades of sustained investment and political cooperation to pull off.
But despite all those challenges, the end goal is what keeps everyone pushing forward. The vision here is for this technology to become the actual cornerstone of a cleaner, more reliable, and truly unified energy strategy for all of Europe.
All right, so let's wrap this up. If you remember nothing else, remember these 3 things. 1, our traditional power grid is straining under a whole new set of pressures it was never built for. 2, a digital twin is basically a live virtual copy that lets us predict the future and optimize the present. And 3, massive projects like TwinOU are already building this future, creating a unified digital grid on a continental scale. Which leaves us with one final, really big question to chew on. We know we need more renewables, we need better energy storage, and we need smarter ways to use power. This technology acts like the brain that can finally connect all those different pieces. So, is a digital twin the final missing piece we need to solve the clean energy puzzle? You know, it really might.